saiga carcasses on a grassland in Kazakhstan in May 2015. Association for the Conservation of Biodiversity, Kazakhstan Biosafety Institute, Gradisky, RK Royal Veterinary College, London. It took just 3 weeks to destroy 60% of the world's saiga population. During an uncommonly warm and wet spell in May 2015, as the endangered antelopes gathered in central Kazakhstan to give birth to their young, a microbe in the animals' absurdly large snouts turned virulent. The saiga's immune systems were powerless against it. Once the disease struck a herd, every member died in a matter of days, first the adults, who suffered diarrhea and respiratory distress, then the young, who starved or sickened themselves by drinking the milk of their dead mothers. Scientists who witnessed the die-off still have visions of carcass-littered grasslands seared in their minds. "It was quite shocking," said Richard Koch, a professor of wildlife health and emerging disease at the Royal Veterinary College in London. Koch has studied mass mortality events for more than 30 years, but what happened to the saiga was unprecedented, he said. It was also mystifying. Pastorella multicoda, the bacterium responsible for the die-off, normally dwells unnoticed in saiga's respiratory tract. What could have triggered the microbe to become suddenly, simultaneously deadly in 200,000 animals scattered across 65,000 square miles of habitat? In a study published Wednesday in the journal Science Advances, Koch and his colleagues identify weather as the culprit. The 2015 mass mortality event, like two previous incidents in the 1980s, coincided with unusually high temperatures and humidity during the spring calving, they report. The animals were in a sort of foggy soup, and it looks like the bacteria naturally occupying the tonsils were woken up by this environmental factor. Koch said. The skull of a male saiga with its horns sawed off. Association for the Conservation of Biodiversity, Kazakhstan Biosafety Institute, Gradisky RK Royal Veterinary College, London. Tracing the saiga's killer was no easy task. The habitat is so remote, and the disease so swift, it was impossible to capture a healthy member of an infected herd for comparison. Instead, the researchers from Europe and Kazakhstan tracked the ailing animals up to a mile a day, performing examinations of diseased and deceased individuals where they fell. The only known survivors were in small herds far from the main group, difficult to pin down amid the vast landscape. After necropsies revealed P. multicoda as the proximate cause of death, the researchers considered a range of factors that might have made the antelopes so vulnerable to a normally benign bacterium. They tested for pathogens that could have increased the danger and looked for evidence of nutritional deficiencies that would have weakened the animal's immune system. They even looked at whether fuel from rocket launchers at Kazakhstan's Baikonur Cosmodrome triggered the outbreak. Yet only 3 variables showed a strong relationship with the 2015 die-off and similar events in 1988 and 1981: average maximum daily relative humidity, average minimum daily temperature and average maximum daily dew point temperature. The scientists are still sorting out the mechanism by which these weather fluctuations change the behavior of the bacterium. They are also quick to point out a connection to weather does not mean the die-off can be blamed on climate change. Climate change is expected to alter the weather in the saiga's native habitat in ways that could make them more vulnerable to outbreaks like the one in 2015. In the past 15 years, scientists have recorded a 10-degree increase in central Kazakhstan's median May temperatures, Koch said, exactly the time of year when the animals gather for spring calving. "We know the trends are moving in that direction," he said. "It's pretty likely that we'll get other events like this again." Stefan Zuda of the Association for the Conservation of Biodiversity, Kazakhstan, and the Frankfurt Zoological Society works with students in the Irgiz region of Kazakhstan in 2016 as they take biological measurements of a calf. Association for the Conservation of Biodiversity, Kazakhstan Biosafety Institute, Gradisky RK Royal Veterinary College, London. Conservationists would be powerless to stop such an outbreak. There is no way to give so many saiga a vaccine for hemorrhagic septicemia, the disease caused by P. multicoda. Figuring out what happened in Kazakhstan could help researchers understand and predict other die-offs, however. Animals and their microbiomes have evolved within certain limits over millions of years, and now suddenly, we're shifting the environmental conditions rapidly outside of that envelope, Koch said. As he and his colleagues hypothesize, you've now got bacteria responding quite quickly, while the host doesn't have the capacity to change. If the immune system doesn't adapt to that quicker change in behavior of the pathogen, that's how the balance is lost. The ramifications could be severe. If this starts happening on a wider scale, Koch continued, it's potentially catastrophic for livestock, for conservation, and ultimately for all mammals. In 2015, the Proceedings of the National Academy of Sciences published a sweeping review of the world's worst mass mortality events, incidents during which either 90% of a species was wiped out, more than 1 billion individuals were killed, or 700 million tons worth of biomatter, the equivalent of nearly 2,000 Empire State Buildings, was destroyed. Since 1940, such events have become more common for birds, fish and marine invertebrates, the researchers found. Most of the time, the die-offs were attributed to multiple stressor problems that piled up until the species reached some kind of vulnerability threshold. In nearly a quarter of all cases, climate played a role. We know these events have been part of the backdrop of what it means to be an organism on planet Earth, said Samuel Fay, an ecologist at Reed University and one of the lead authors of the PNAS study. He pointed to the spectacular dinosaur graveyards left behind by floods and mudslides, and even the grim ruins uncovered at Pompeii. But we also know that patterns of local environmental conditions are changing, Fay said. And our science is advanced enough to say that it seems reasonable that given those types of extremes, there's the potential for mass mortality events to occur. A newborn Saiga calf nestling in the arms of a scientist from the Joint Health Monitoring Team. Association for the Conservation of Biodiversity, Kazakhstan, Biosafety Institute, Gradisky RK, Royal Veterinary College, London. As for the Saiga, the outlook for the imperiled antelope species remains unclear. These holdovers from the Ice Age are tough creatures, evolved over tens of thousands of years to survive the harsh conditions of their habitats. In the past century alone they've rebounded twice from the brink of extinction. But the past few years have been especially hard. Last winter, the Wildlife Conservation Society reported that a quarter of a Mongolian subspecies hundreds of miles away had succumbed to an unrelated virus. These populations are highly vulnerable to the introduction of new diseases and the stress that goes along with that and factors that can trigger it. Society veterinarian Amanda Fine told The Washington Post at the time. Read more. The imperiled Saiga antelope is struck by a plague. Again, starvation killed 80,000 reindeer after unusual Arctic rains cut off the animal's food supply, and pitiful animal die-offs across the globe, from antelopes to bees to seabirds. Climate change may be culprit.